Afternoon, my YouTube viewers. It is Crystal here, and I wanted to make you another video. This video is going to be on a Kaggle competition question. It's going to be on the competition question for January. So it's going to be Season 5, Episode 1. And on this competition question, the problem statement is to predict on sticker sales. And basically what I did was I did the competition on a Jupyter Notebook. And the first thing I did was on linear regression. It performed very poorly. And then I tried it on extra trees, and it did better. And then I tried it on doing a time series for extra trees, and it did better with that. And I actually got the time series for extra trees from a notebook that somebody else made. I got that particular block of code from a notebook somebody else made, and this person got a silver medal on it. So what I'm going to do is I'm going to go ahead and commence with the code review. So we've already talked about our problem statement, which is to predict on sticker sales. And the next thing we're going to do is we're going to import libraries. So we're going to import pandas as PD to create the data frames and process the data. We're going to import NumPy as NP to perform numerical computations. We're going to import OS to go into the operating system. We're going to import sklearn to provide machine learning functionality. And I will say that on sklearn, I imported the mean squared error, but there's another test called absolute mean error. I'll look at it. I can't find it. Let me just look and see. Mean absolute percentage error. And I didn't know if it was on sklearn. I didn't really look at the front of the front page to say how they were measuring it. I just used mean error. And here we go. On the front page, it's telling you that the submissions are evaluated using mean absolute percentage error. And sklearn, which is the library that I use to give me my machine learning functionality, does actually have that metric. So I could have used that metric if I had been a little bit more critical, but there's no guarantee, because sometimes what Kaggle uses, metrics that are not yet in sklearn, or they're not using the most current revision. And because they're not using the most current revision, these metrics are not in sklearn. But that's what I should have used. I should have used mean absolute percentage error. But what I did is I used root mean squared error, which is the metric that I normally use. So I just wanted to let you know that. So like if you want to do this competition, you can know that sklearn does have the mean absolute percentage error. And you don't have to use mean squared error if you don't want to. And sklearn also has a root mean squared error. But the thing about the root mean squared error is sklearn does not use the most current version. Kaggle does not use the most current version of sklearn in their Jupyter Notebook. So it won't come up. And that's why I use mean squared error instead of root mean squared error. But sklearn does have a root mean squared error as well. And then I imported PyLab. That is something for statistics. And then I imported statistics, scipy.stats, stats, that's statistics. And then imported matplotlib.pyplot as PLT to visualize the data. And then I imported seedborn as SNS to statistically visualize the data. So those are the libraries that I imported. So we're going to use OS to go into the operating system and retrieve the files. And the 3 files that we retrieved were train, test, and sample submission. And then we're going to use pandas to read the CSV files and convert them to data frames. So we converted them to data frames, and the 3 data frames are train, test, and submission. So this is train, and so you can see they've got an ID, a date, a country, discount stores, product, and number sold. So the date is an object. And now we've got info. You can see that the ID is an integer, the date, country, store, and product are objects, and number sold is a float. We want to see if we have any missing values. And number sold, you have 8871 missing values. So what I did was I just dropped all of the missing values in the train set. And then when you drop the missing values in the train set, then you had 8871 less rows of data. And then so what I wanted to do was I wanted to see the number of unique values in each column of data. So for call and train, print the column and then train call dot unique in unique. And so that told you that country, there were 6 unique values. Store, there were 3 unique values. And product, there were 5 unique values. So that's what we want to focus on. So we also wanted, so it said what I did was for every unique value that was less than 7, I wanted to print those unique values off in those columns. So for country, you had Canada, Finland, Italy, Kenya, Norway, Singapore. For store, you had discount stickers, stickers for less, premium sticker mark. And for product, you had Kaggle, Kaggle tiers, kernel or dark mode, and holographic goose. So now what we're going to do is we're going to analyze the country so you can see how many rows of data you have for each country. And then we're going to analyze the store. You can see how many stores you had for each particular store. And then now we're going to check product. You can say how many products you had for each particular product. So now we're going to check the test data frame, and with the test data frame, we're going to do exactly what we did with the train data frame. So we checked to see how many unique values we had in the test data set. And so country was 6, store was 3, product was 5. We're going to print off the categorical, the different unique values for each column of data that was less than 7. And it was the same. Let me just see this. This says for country, it was Canada, Finland, Italy, Kenya, Norway, Singapore. For store, it was discount stickers, stickers for less, and premium sticker mark. And for product, it was holographic goose, Kaggle, Kaggle tiers, kerneler, and kerneler dark mode. I just want to see if there was a kerneler dark mode. Yeah, there was a kerneler dark mode in that. And then so you can see that in the test data set, because we did not remove any null values because there were not any null values to move, you can see that you have the same number of rows for each country, the same number of rows for each store, and the same number of rows for each product. So now we check for null values. We didn't have any null values in the test set. And now we look at the submission file. The submission file is what Kaggle wants to see when you submit your work. So they want to see an ID number and they want to see the number of items sold. So now I'm going to analyze the target. Target equals train pop num sold, and then we're going to make a histogram of that, and we're going to have 50 bins. So this is the histogram of the target. So you can see that we have more items of 0 than we have any other. And you can see that as the number of sold increases, the number of rows where that value appears is going to decrease. So you're going to have a smaller number of items sold than you do have larger number of items sold. For instance, if you had 2,000 items sold, that's going to be like maybe 2,000 rows of data. If you had 0 items sold, that's going to be over 4,000 items of data. So we're going to drop the ID in the training set and the test set. And the reason why we do that is because Pandas automatically indexes every row of data, so you don't need an ID. We're going to encode the object columns. So for every we're going to use ENC, that's encoder, equals ordinal encoder, handle unknown equals a use encoded value, and unknown value is -1. So for column in train, if train call.dtype equals object, and then train call equals ENC dot fit transform brackets train call dot values dot reshape -1, 1 bracket, and then the next line is test call equals nc dot transform brackets test call dot values dot reshape brackets -1, 1. And then so after we can encode our object columns, then what we're going to do is we're going to convert the date to days, years. So what I'm thinking is, let me check the date here. What I'm thinking is I can redo this, and if I redo it, then there is the possibility that I can get a better score. That's what I'm thinking, because I did the dates after I encoded it, and the date is actually an object. And since the date is actually an object, there's a possibility I can improve my score if I take this code here, the def transformer, and then I put it before the object encoder. And if I put it in before the object encoder, then I think I will get a more accurate reading. And then so that's what I'm going to do. And then so you got your train equals transform date, train date, test equals transform date, test date. And then we're going to drop the date because you don't need it. And then what we're going to do is we're going to define our dependent and independent variables. So y equals target, x equals train, x test equals test. And then we're going to use sklearn to split the data set into training and validation sets. We're going to define our model, and when we define our model, we're going to use extra trees regressor, and we had 94% accuracy on that. And I was a little bit worried about that, but after I do what I said to you that I was going to do, and that might actually improve my score. And then so we predict on the validation set, we get the root means squared error, which is 171, which I was a little bit worried about that too. And we're going to make a QQ plot we're going to make a QQ plot here. And then, because you need to do a QQ plot, and I was a little bit worried about that. And then we're going to visualize the predictions. I was a little bit worried about those predictions as well. And then what we're going to do is we're going to predict on the test set. And then when we predict on the test set, we're going to make our submission. And so we're going to take the prediction and we're going to put it in the number sold column, and we're going to convert it to a CSV file, and then we're going to convert the CSV file to a data frame, and then when we convert the CSV file to the data frame, we've got our ID number and the number sold, and we're going to submit our work to Kaggle. In this particular instance, I got 0.46. But what I'm going to do, which is what I've already said I was going to do, is I'm going to take this code right here, see if I can find it. This code right here, I'm going to put it before the encode object columns and then see if that improves my score. So that's what I'm going to do with this particular Kaggle Jupyter Notebook. I can see if I can get a better score by doing that. And what I will do is I will conclude this video because I did the code review, and I will leave a link to the workbook in the YouTube video description box so you can see it and see where we go from there, see if we can improve our score. So thank you so much for watching my video and going over the code review with me and helping me pick out a mistake that I made. And so hopefully I'll correct that mistake and I'll get a better score. So if you like my video, please like and subscribe. And I look forward to making more technical videos for you in the future.